Yes. Now in the question number 1, there is a beam, and in this beam we have two cylinders is attached. Cylinder A contains water and cylinder B contains load. Load mean a weight, heavy object. Now initially a large weight of water in cylinder pushes piston down. It is obvious that once we try to balance, so we apply weight, and if the weight is heavy, so definitely this connecting rod will move down from the weight side. So this causes the left hand end of the beam move down and the right hand end of the beam moves up. Piston B, this is your piston B, rises, lifting the heavy load. The weight of cylinder A is 80 kilonewton. What is Kn? Kn stands for kilonewton, right? Kilonewton. Calculate the mass of water in cylinder A. So first of all, that's you're talking about the weight is kilonewton. Kilonewton mean 80 kilonewton mean 80 multiplied by 1000, because kilo is actually equals to 1000, right? So we know about the formula of weight. W is equals to mg. So asking for the mass, so W over G is equals to M. This is our formula. So W weight is equals to 80,000, and the value of G is constant, that is 10 into M. So this is very simple. 0 to 0 cancel. So mass value becomes 8,000 kilogram. Now calculate the density. Sorry. Calculate the volume of water in cylinder A if the density becomes 10,000 kilogram per meter cube. So density formula we know, that is mass upon volume, right? So we have density, we have mass in the previous part, that is 8,000 kilogram. So if you want to calculate the volume, so volume is equals to mass over density. Then simply putting all the values, mass will be 8,000 divided by density 1000. The volume should be 8.0 meter cube. Remember the unit, please. The mass unit is kilogram and volume is meter cube. Okay. Now, this is a exceptional part. Calculate the potential energy if piston A moves down by the distance of 4 meters. So potential energy formula is mgh. M is for mass, that is 8,000. The value of G is fixed, 10, and G h height is 4. So simply multiply. This is 32,000, 320,000, and unit is joules. Okay. Efficiency is actually a percentage, that is useful power output, or you can say energy output, over energy input. So this is our output value, right? So the heavy load lifted by the piston gains 96 kilojoules of the gravitational potential energy. So this is the value that we have calculated, 320,000 joules. So this is our input, and 96 kilojoule of energy is your output. 96 kilo mean this is 96 multiplied by 1000 divided by 320,000. So simply 0 to 0 cancel, multiply by 100 as well. So 96 multiplied by 10 divided by 32, 30%. Right? For these part C and part D, you may also check the lecture of energy on the channel. I will give the link in the description as well. So it will better to understand about the part C, the potential energy and the efficiency one. Right? Now, this is important question. First of all, we have a slab, shows a uniform rectangular slab of concrete having sides A, B, C, D, standing upright on the ground. And the slab height becomes 0.6, width is 0.3, and mass is 18 kilograms. Okay. A force of 40 Newton acts horizontally to the left. That means it is exactly tilting downwards. So first of all, calculate the weight of the concrete slab. Weight of the concrete slab. Right? The force is applied is 40 Newton. So we know that the formula for the weight, that is W is equals to mg. What is m? 18, and
Mass.
g is 10. So simply you have to multiply this 180 newtons. Newton is a unit of weight. Symbol you have to write only 180 n. That's okay. Now The thickness of the slab is given. Thickness of the slab is 0.04 meters. Okay. And the surface width is 0.3. So first of all, you have to find area. Do you know what is the formula for area? In the mathematics, we use length into thickness. Yeah, breadth. What is the length? 0.3 multiply 0.04. 0.3 multiply 0.04. That is 0.012 meter square. Okay. After that, you know the formula for the pressure that we have learned. F over A, force upon area. Okay. So force, that is your weight, which is applied. So we can write this. P is equals to W upon A. So simply putting the values, what we get? 180 upon 0.012. Answer is 15,000 Pascal. Pascal is a unit of pressure, or you may write PA. Right? If we want to calculate the volume of this rectangular slab, so we simply multiply length into breadth into height. Okay. So length into breadth into height mean length becomes 0.3, width or thickness breadth, that is 0.04, and height becomes 0.6. So what should be the volume? 0.3 multiply 0.04 multiply 0.6. That is 7.2 exponential minus 3 meter cube. All right. 7.3 exponential minus 3 meter cube. Now we have mass of this slab is 18 kilogram. Now if we want to calculate the density of the slab, density, what is the formula for the density? Density is equals to mass upon volume. What is mass exactly? 18. Volume is 7.2 exponential minus 3. So 18 divided by answer. So density will be 2500 kilogram per meter cube. So in your exam, these kind of questions may be asked frequently, especially for the weight, area, volume, and density. A large screen has a mass of 8500 8500. Calculate the weight. Now again, formula of the weight becomes W is equals to mg. W is equals to mass 8500, g value is 10. So what should be the weight? 85,000 newtons. right? And we have this time area, contact area is 3.4 meter square. So pressure becomes F upon A, or this is your force. So this is again right W over T, weight multiplied by, sorry, T, not T, sorry, A. So pressure becomes 85,000 divided by 3.4. You will get a very huge value, 3.4. This is your 25,000 pascals. Okay. Now a few MCQs. This is your paper 1 MCQs. Okay. An object has mass 50 kilogram and the gravitational field strength on Earth is 10. Gravitational field strength is exactly gravity value on Earth is 10 and mass value is 50. The gravitational field strength on distant planet is 4. So what is the weight of the object on Earth and what is the weight on the distant planet? So mass is 50. Mass is 50. So you know that about the weight formula, that is W is equals to mg. Okay. So weight on Earth, the weight on Earth becomes mass 50 multiplied by 10. So weight will be 500 newtons. Weight on Earth, asking for weight, 500 newtons. And weight of the object on Earth and weight on the distant planet. The same way we can solve again, but gravity value will be different. Mass is same 50. Gravity on the distant planet is 4.0. The weight will be 200 newtons. This is Earth and this is another planet. So D. And remember one thing. Remember one thing. Mass remains same everywhere, but weight will be different everywhere, depends upon the surface gravity. Got it? Depends upon the surface gravity. As we see, the same object, mass is same 50-50, but the weight becomes different. On Earth, this is 500, and on other planet, this is 200. So remember, mass remains unchanged, but weight will be decreased if the gravity value will be decreased. Okay? Now, this is a part of a measurement question. A car travels 100 km, takes 2 hours journey. Highest speed is 80 and the lowest speed is 40. Calculate the average speed of the car. So how can we take average? So you should know about the highest value and the lowest value. right? And then the total journey we have 100 kilometer for 2 hours. So 100 divided by 2. So how can we take the average value? Speed is equals to distance over time. So we have distance 100 time 2 hours. So this is 50 kilometer per hour. Simple question. Measurement question. Okay. Remember that the gravity of the moon is less than Earth. Okay. So what should be the value of weight? What should be the value of weight? It is less than 5 or equal to 5. Is the mass will
Yes.
same or unchanged? Mass will be same and unchanged everywhere. Okay. Mass remains same everywhere, either on the moon or somewhere else. Weight will be changed. So mass should be same as Earth, 5. Now, which statement about mass or weight is correct? Weight is a force, obviously. What is the weight of an object? The weight of an object is exactly the force of gravity is called weight.
Yes.
Hmm. Confusion?
No.
So in this session, we have solved few MCQs as well for the reference. Inshallah, in the next session, we will solve further questions of the same topical. And if you want to learn any particular topic, so you can comment on that. So till then, take care. This is Dr. Najam signing out. Assalamu alaikum wa rahmatullahi wa barakatuh.